All right, our next speaker is Hannes Hapke, who is a principal machine learning engineer at Digits, co-author of multiple O'Reilly books. He's a Google developer expert for machine learning, and today he is sharing his talk, The Hard Truth About AI Agents. Candid insights from running user-facing agents in production, including the challenges that nobody's talking about in their demos. So please take a moment with me and welcome Hannes.
Thank you for the kind introduction. My name is Hannes. So this joke is pretty old, like sell me this pen, but these days, the pen is agentic. Everything we talk about is agentic. We're living in a world where, like, I don't know if it is because of VCs want to increase their multipliers or something. We talk about nowadays not about AI anymore, we talk about agents. And so I want to spend a little bit of time to talk about what does it actually mean to bring agents into production. So the purpose of the talk is to avoid that scenario for you, that you don't end up in this weird moment when you add something to your product and it's not really fitting and you don't really get the soap out of that soap. My name is Hannes. I'm a machine learning engineer at Digits. I've been in the field of machine learning in various verticals for the last 10 years and had the chance to implement various applications and various types of models. And I also had the chance to co-author a couple of books, and the most recent one, which is coming out in 2 months, is all about RAGs, agents, and those types of things, and what are the design patterns. Not so much about explaining how they work behind the scenes, but sort of like what are the best practices you can apply to bring them into your products. Alan mentioned Digits earlier. What are we actually doing? Just to set the stage here, we developing accounting software for startups and small businesses because most of the small businesses in this country cannot afford an accountant. And so the premise we have is, like, we build machine learning tools and the software around it that automates the entire accounting process for small businesses and does that in real time. And as you can imagine, there's lots of machine learning involved. So this is basically a quick screenshot of the app, but like basically we do everything in real time. You don't have to wait for your accountant to come back with the answers. Quick agenda for today. The big question is, like, what is an agent? We check this off really quickly, but then I want to talk about the agent infrastructure behind the scenes. What does it actually take to get this to run? And then what are the lessons learned we have discovered over the last 12 to 18 months? All right, so when I talk to my parents about agents, they think of this, or they think of him, but their work patterns are probably non-deterministic, and they often have a chaotic outcome, or they're like a catastrophic outcome. But in agents, we actually want the complete opposite. We want high transparency, not secrecy. We want a deterministic outcome, and we want probably nothing should blow up or nobody should die. So I truly believe it's the wrong name. It's just the name seems very hype-driven. So just like a little side comment here. Maybe we should just call it just process daemon, but I don't think you can raise billions of dollars with that name. So let's go back to agents. What is an agent? So an agent has an objective. We go to a large language model. The large language model then can decide whether it uses internal knowledge or it goes to a tool, as we just heard in the previous talk. And then it does this loop until it thinks the task is completed and it returns a response. Seems pretty straightforward. That in itself could be implemented in 100 lines of code. Very straightforward. So like, why is that such a big deal these days? So, is it actually 100 lines of code? Well, let's discover that together. So, to give you a little bit more context here, what are we using those process daemons? It's the last time I used this term, but what we use those process daemons for? And the applications we have are Sometimes we want to hydrate vendor information. So let's say we get a transaction from a vendor we have never seen before, but in the app we want to show this with nice annotations. We want to show a website, a logo, etc. Agents go out and grab those information. We want to simplify the onboarding for clients. Often when you have an accounting software, you get asked a lot of questions. But these days we have tools that they can answer those questions, and we can actually simplify the onboarding process. And then we can also handle complex user questions. You will see a little demo later, hopefully, when everything works. So the question is now, can we solve those tools or those tasks within 100 lines of the code? Maybe. Let's start with the language model itself. These days, you can integrate like model providers like OpenAI, Anthropic, and so on. But you can also use open source models. You don't have to host them yourselves. You can use like companies like Together AI or Base 10. They host those models for you in a relatively secure environment. But those are options you can use to power the capabilities of the agent. The next thing what you would have to do is like you have to design your agent itself. Right? There's like open source frameworks available. There's like LangChain, Crew AI, etc. But they come with a slew of complexity. Like the dependencies of those frameworks are incredible. We'll talk about them in a little bit as well. Then the next step is you have to define your tools. And as we just learned from the previous talk, you define them, and in some companies, they implement everything in Python. So for them, it's just like copy pasta. They have some API, and they can move this over to their tool definition for the agents. That is easy. I work for a company, we don't have any Python in production, so I can't do the copy pasta thing. We have Java, Kotlin, and Golang in production, so it's a little bit harder. So then the big question is like, what do we do actually here? But like we would have to give the LLM access to a certain set of tools internally. And the interesting thing what we discovered was like we already have those APIs internally. We're not talking about an MCP setup here, but we're just like have internal APIs that we can reuse. They already have been defined through RPCs. And the idea we had was like, why couldn't we reuse them? Those RPCs are really well defined in terms of what are the inputs, what are the outputs. Those APIs have like authentication already attached to it. So we just use them in our tools. And we'll get back to this in a little bit, how we use them. The next thing is what we need in our infrastructure is like we need to observe those agents. We just don't want to let them run freely. There's lots of like open source tools available, FreePlay, Phoenix, etc. There's also paid products out there. They allow you to see what is actually happening between those different tool calls. When you have a normal LLM call, it's pretty easy to sort of like check what was the input, what was the output. When you have an agent and the agent does that agentic loop, it's really difficult to track those different sessions. So those tools help you to keep everything in check. Here's a little screenshot. I'll show you a little demo later, but like you see information about how long does it take to execute the entire session, what is potentially failing, what are sort of the events happening behind the scenes. You see the prompt, the input, the output, what tools have we called here. You can see sometimes when we started using the tool, we discovered sometimes the agent runs in circles until it sort of like decides to break that recursion loop. So there's like a lot of discovery available through those observability tools. And then everybody these days talks about memory. And there's lots of open source options there as well. And if everything works out, I have a little demo later how we use those memory scenarios or how we can use them. And the interesting thing is with all those tools, whether it's the observability tool or the memory tool, you can treat them as microservices. You do not have to implement them yourself. There's lots of like options available like mem0, langgraph, or langmem memory, etc. But they have, what they give you is like, not just like a database behind the scenes, but it's also a semantic search. Sometimes they have a graph database. They combine the insights from different databases, and then at the same time, they mix and match, or they figure out like what if the context is actually relevant to the entire session. And then we talked about guardrails. Very critical. You should not trust your large language model, regardless of where that large language model comes from. You can start with a simple, simple LLM call to evaluate the initial response, but never use the exact same large language model. So maybe switch providers or like switch model types or something. Otherwise, if the same model is evaluating what it did already previously, it's like giving the test to the same student back and say like, hey, grade yourself. Right? We know how this ends. There are some tools out there like Guardrails AI. They allow like more complex scenarios. They allow you to detect hallucinations. They have like policies. So sometimes maybe you have like a question for like something HR related that needs to be very more certain, or something security related than just like a quick FAQ question. So this is where we started. This is what we had earlier. So we just said there's an objective, there's a large language model in between, and that decides which tool to call, and then it put out a response. So, but I mentioned all these like infrastructure pieces, so how do they actually fit together? So at some point we want to know what's the memory, because our context, if we do this often enough, gets way too long, and we need to figure out what is actually relevant in this entire session. So that's what we use the memory for. Sometimes we want to then, in between, retrieve documents. So maybe you have a retrieval augmented generation system, and that gets you the documents. So you want to talk to another system that actually gets you contracts or FAQ documents, etc. Then you switch out the LLM to like an LLM proxy. Maybe you need a failover. Maybe you want to switch easily between different models, and you have a proxy in between, and you just basically tag it, and the proxy does the routing. So it helps you with like failover protection. It helps you with rate limitings and routings and various things like that. Then we just added the observability. Right? The cool thing about LLMs is that they can be reflective. Like you can give the final response back and say like, is this a correct answer? Does it make sense to what we wanted to know in our initial objective? So you can have a feedback loop here before you give it back to the user, and then say like, does it actually make sense, or should we restart this whole process? And then in between we said like, oops, we want to check before we give it back to the user, we want to check, does it actually make sense? Let's add some guardrails. So yes, so this initial implementation is 100 lines of code, but then there's a lot of infrastructure we need around it for the various tasks. So did we all implement this ourselves? No. What are the lessons learned? There's a couple things here. In terms of frameworks, we stayed away from any framework. They're extremely good for prototyping. So I personally use Kuro AI, some colleagues use LangChain. They're extremely wonderful. If you have an idea, you want to bootstrap something, you tap into your data sources, within minutes or maybe a couple hours, you have a fully functioning agent put together that gives your managers like confidence that this could be a good production project. But those frameworks have horrendous dependencies. That dependency is like a security nightmare. So what we decided, like, we implement the agentic loop ourselves. So those 100 lines of code, we basically replicated this in Golang, and then used the entire infrastructure as a microservice. So we have like a microservice that is handling the memory, etc. We do like a call to a separate LLM for the guardrailing, etc. All right, then in terms of tooling, we tried out many things. So the initial path is, as I explained, you would define those tools manually. That is often very cumbersome. In our case, it's also like we would have to replicate our a good chunk of our API stack. And that's not something what we wanted to do. We tried to use RPCs directly. So RPCs is like a protocol that came from Google. That's how they define their APIs, and that can be converted into any programming language. We tried to use this. We tried to use this as a basis, but it was extremely noisy. The nice thing is, in those RPCs, you can leave comments, and then you can use like Golang reflections. In our case, you can inspect those APIs, get those comments, and from them you can curate your APIs or your tools. And then basically what we get out of it is a JSON structure that we put together with the task objective, and that becomes the task objective comes from the comment in those APIs, and that's what gives us the tool itself, the tool definition. And the nice benefit of that is because those are APIs, internal APIs, they have to handle all the authentication already. So we give the agent a certain user interface or certain authentication, and then the API automatically has to handle that from behind the scenes. Observability is critical. Like, we learned so much about our initial agent implementations when we roll out observability. That was like eye-opening. We had an agent running in production for probably a year before we rolled out this tool. And then we figured out, I was like, oh man, this is like sometimes running in a loop. We waste too many tokens. Like, this is like really not what we had expected. We settled on a tool that supported OpenTelemetry, because that is a common standard when folks use the DevOps side behind the scenes. And a lot of observability tools support this now. So sometimes when you have like an OpenTelemetry message you send out, you can actually define like two different destinations, and one destination is our LLM tracking tool. And then in terms of memory, I always heard this argument of like, we just built this context, we just put it together, and just the storage basically is my memory. Well, I'll show you an example here in a second. That is not the case, I hope, if everything works. And we use the memory tool. We stay away from the memory tool of model providers. In the past, OpenAI had this really wonderful product. They offered the memory behind the scenes. But what happens there is it basically creates this vendor lock. So because everything is built on top of that memory, you can't just easily switch to Anthropic, or you can't just roll out an open source model. So this is where things get a little bit tricky. So highly recommend to implement the memory as a part of your own infrastructure. That prevents that vendor lock. So it's the first time ever that I try to do a live demo in a talk, so let's see how that goes. Yep. Gonna be interesting. That's my screen, yeah, true. Okay. I wrote a little demo app here to show you the implication of a memory. And I asked, that demo app is like, I'm sorry, it's a chat interface, but it was the quickest one to bootstrap. Just is a little travel planning agent. And it's like, help me to plan a trip to LA. It gives me like a little couple options here, and then I was like, actually, I prefer vegetarian food. Just as a random example here, we chat a little bit more. Can you recommend me some museums? Can you recommend some concert venues? Yada, yada, yada. And then, is it actually safe to use public transit? And then at the end, I was like, oh, now help me to plan a trip to Asheville. Right? And the agent recommends me barbecue places, which is nice, but I asked for vegetarian. Like, it should, I don't know, whatever. It should know this. Like, but this is the perfect example where like it just dropped off the context. It's like my request for vegetarian restaurants is already gone, and we maxed out on this token length. So then I have another agent that got the exact same questions, and it gave me the exact same answers so far. And so now we're like, let's see if that works. it just errored out earlier because like it was always like not helping me with, it ran out of tokens. So let's see what happens here. But the interesting thing is like what happens behind the scenes is for every user, oh, that's sad. What behind the scenes, every user, it basically creates a profile. This is what you can see in the side menu here. I have food preferences, I have accommodation preferences. I define this for my app. What is actually, what do I want to keep in that context? What's really critical to this conversation? And then if I try to rerun this here real quick, maybe it's nicer. You can also inspect what's happening behind the scenes. Got rate limited again. Okay. So what you would see there is basically what if I wouldn't get rate limited right now, it is that you basically get vegetarian restaurants recommended in Nashville, and that's the whole purpose of that memory application. All right, one big thing what we introduced, and it's less of an infrastructure piece, is that we asked the agent at the beginning to do task planning. Basically, the first task we always injected was like, go out, use a reasoning model to plan your tasks. And what we noticed is like that task planning heavily reduced the sort of like recursive tool calling. It became more like a checklist at the end of the day. So heavily reduced the overall task latency. We introduced guardrails. We started with a very simple approach of like going out to another LLM and reevaluate what you just produced, where we went to like a different provider, or sometimes we use like a reasoning model. And we've seen some really good results there. It is so far a very simple approach, but like that helps us to avoid the complexity of the overall system. And then in terms of like responsible agents, yes, we introduced the observability. We saw some really good failure cases there to improve them. That was a really good internal feedback loop. We offer feedback mechanisms for the user to say like, this is not a good response here. We use guardrails, and then we have a Slack channel where we see responses that fail, and we investigate them and see what's going on. And then in terms of improving agents, I think this is a super interesting topic. It's probably a good topic for another talk, is like we try to capture user feedback, and we want to then design reward functions to improve the underlying machine learning or LLM model. I think it's super interesting topic, so if anybody wants to talk about reinforcement learning, I'm happy to chat later during the drinks. And this was basically an almost MCP-free talk, because we evaluated MCP previously, and it turned out that we felt like it is way too complex for us. Since we have those tools already available, we have those definitions, we can just move them over and generate those tool definitions. And so therefore, it feels like the MCP is perfect if I want to talk to external sources. So that seems to be great if I integrate, as we have seen with Slack and other external APIs. And then one more quick demo to actually show what's happening here. So this is basically our app, and I can ask any questions about like my fake. Oh, okay. Hold on. Let me share this screen again. So this is the app we have. You can. This is a fake account. You can ask questions about like what happens. Sorry, it's a chat interface again, but we also concluded that chat might not be the best option to get insights here. But like at the moment, you can ask something like, what's the ratio between expenses and payroll taxes. Let's see what happens here. Oh, I get a great, can't send it yet. Oh, wait, interesting. So Then we have our our Phoenix setup here, and we had a quick agent run. So something obviously failed, and we got a weird response back. And so here we have our complete prompt, and we saw our initial user questions. So we can now investigate why this actually failed. So this is gives me some insights of this clearly did not go anywhere where I wanted to be. So normally when I ask this question, I would figure out the categories and then do the math and then respond back with a really good answer that apparently in my demo account I spent 8% on, it would be the ratio would be 8% between taxes and salary. So quick conclusions. So yeah, don't rely on agent frameworks. Implement the core loop yourself, and then reuse the infrastructure from open source projects. And in terms of applications, or in terms of the infrastructure, let it drive by what you need. Don't set up all the tools, as I showed from day one. You can start maybe simple, and then bring in those tools. Whenever you need the memory, you bring in the memory, and start to grow your infrastructure from there. Cool. Thank you.
Thank you. We have time for just one question. Anyone from the audience? All right. Oh, there is a question here. Hang on one sec. I'll get the mic.
You mentioned something about creating a rewarding system for the LLM. Can you speak a little bit about that, what that would look like, a reward for the LLM?
Yes. So what you would do is, in your, for example, you have a chat interface. Throughout the conversation, you could ask your user, how helpful has the response been? That gives you a general feedback about that conversation. And then you could, so this gives you a positive or negative signal. And then when you have a reward function that you can design was okay, if it's a positive signal and it touches on, in my travel example, it touches on hotels, or it mentions restaurants or something, then you give it an upvote or a downvote. So you build your custom reward function based on what your overall objective is. And then you're gonna have some negative examples where people say oh, sorry, this is completely irrelevant to my question. And those become positive and negative examples for your retraining cycle. So then you would take a model and train it on those examples. And that's basically what DeepSeek and OpenAI and all these companies do. When we use ChatGPT, at some point we say this was bad or this was good. This is how we feed their cycle.
Awesome. Thank you.
Thank you.
A hand for Hannes.